Hello friends, in this session I'm going to discuss about deadlock prevention. So in the very first video of deadlock, I had discussed some basic conditions of or some basic scenarios in which a deadlock can occur, right? So what were those conditions? They were mutual exclusion, hold and wait, no preemption and circular wait. Now when we talk about deadlock prevention, we say that what should be done in order to say that deadlock should not occur or deadlock does not occur, right? So in that case, what we try to do is we try to make any one of those conditions, any one of those four conditions false. So that is the only solution of deadlock prevention. Although there are some algorithms also in correspondence to deadlock prevention and deadlock avoidance, which I'll be discussing in the future videos. In this session, I'm going to discuss what are the basic things or basic techniques in which you can prevent a deadlock. So the first basic condition or basic situation or basic solution is to make mutual exclusion false. So as we had discussed in the first video, mutual exclusion was what? It was basically when only a single process is allowed to execute upon a particular resource. That is, we do not allow for resource sharing. So by making mutual exclusion false, what do we say is we are now allowing resource sharing between the processes. Now since there is resource sharing between the processes now won't be waiting for any resource instance, right? So now if a particular process is not waiting for any particular resource instance and they are getting the resource instances, that means there will be no deadlock. The second condition is making hold and wait false. So what was hold and wait? If we would just recap, hold and wait was when a particular process is holding a set of certain resource instances or resources and is also requesting for some other resource, such a process can be responsible for creating a deadlock. Now how can such a process be responsible for creating a deadlock? Because it can happen that particular process is holding a certain resource which is required by some other process, which is in turn waiting for that resource. So now till this particular process completes, the other process cannot complete. So I'll just explain that scenario. Let's say I'll just diagrammatically draw that. So let's say if P1 process, this is my R1 resource which has been assigned to P1. Note, this has been assigned to P1 and it is not requesting for R1. So it is requesting for R2, let's say. It is requesting for R2. Fine. But there is another process, P2, which is waiting for. Now this R2 is again held by, let's say, P3. Fine. So now just think upon this scenario. Till this P3 completes, it is not going to release R2. Till the time it releases R2, P1 is continuously just waiting for R2 and it is also holding R1. So until the time that P1 completes, P2 is not going to start its working because it eventually requires R1, which is now held by P1. So now what is happening is P2 is waiting for P1 to complete and P1 is waiting for P3 to complete. But let's suppose I wouldn't have allowed this situation that a process which is waiting for some other resource can keep some resources in its hand. So it can hold some other resource. If I would have not allowed this situation, this R1 would have been free and P2 would have not been waiting for any other resource, right? So this situation would have not occurred. Although this is not a deadlock which we can say, because P3 can complete and then P1 can complete and eventually P2 can complete. But what I was trying to explain was the hold and wait scenario. So in this case, P1 is holding some resource and it is waiting for some other resource. So that was the hold and wait thing. So now if I would have to explain the hold and wait scenario of creating a deadlock, I would take up this example. In this case, this is an example from my previous video of resource allocation graph. So now in this case, P2 is holding this resource, it is waiting for this. P3 is holding this R2 and waiting for R1, and a cycle is being formed and both the processes are in deadlock. So this is just an example of deadlock in which hold and wait contributes. So now if we make this hold and wait false, deadlock can be avoided. Now allocate all the resources. What are the situations, what are the solutions in which it can be made false? We can say that allocate all the resources to all the processes that require them before the execution. That is, I have allocated all the resources to all the processes that require them before the execution. Problem is, let's suppose I allocate all the resources to P1 in the beginning itself, then all the other processes are waiting for all the resources, since all the resources have been assigned to a particular process P1. Now it might have happened that P1 never ever requires the need of a resource R3, but since all the resources had been assigned to P1, the processes which require R3 are unnecessarily waiting. So the disadvantage in this case is poor resource utilization. The next situation is when a process requests a resource, then before it gets the grant of this resource, it has to release all the resources being held by it. So this can be a possible solution which we can say, in which we can just make this hold and wait false and avoid deadlock. The third is make no preemption false. Now what was no preemption? No preemption was that, let's say a process is holding some resources, but somehow it is not able to complete. Let's say it was waiting for some other resource, or it is taking too long to complete, and because of this process, because this process is not able to complete, some other processes waiting for the resources held by this process are now just in deadlock. So in that situation, what we can do is, in that situation, we can allow for preemption. Preemption is, you can preempt, you can forcefully take away those resources from this particular process and assign them to the other processes, and then when they are done, you can again assign those preempted resources to this particular process. In this situation, what would happen is, maybe the other resources might be holding some other processes, maybe the other processes which were now waiting are first of all, they are able to complete. Secondly, they might release some extra resources which this particular process was in need of. Fine. So in that situation, what can happen is, we can entirely remove that deadlock from our system. So what we can say is, just the explanation is, when a process requests for a resource, then the operating system checks whether the resource is available or not. If the resource is not available, then the operating system checks for the requested resource. The requested resource, if held by another process, then the operating system preempts that resource, right? So it preempts that resource from the waiting process and allocates it to the requesting process. So this is in the manner we just execute preemption, or we can say we make the no preemption false. Finally, the last condition is making circular wait false. Now what does this mean is that circular wait was when a number of processes are waiting for each other, and they are waiting for each other in a cycle such that they are in a particular order. They are in a particular order of their indexes. So this was again explained in the first video. You can please go back to that video and take a look on it. So in this case, how we can remove this circular wait, or how we can make circular wait false is, allocate a number to each resource. First of all, allocate a number to each resource. Then a process always requests the resource in the increasing order of the resources. So it always requests the resource in the increasing order, means basically if a process P1 is requesting for resources, it can request for R1, R2, R3, let's say R5, but it cannot request for R4 now, because as per the increasing order, it can request for any other resource with index more than 5. So this is what we mean from increasing order. A process cannot request for a lower numbered resource if it has higher numbered resource allocated. So this is again explained in the same manner. Then the request for now in this situation, let's suppose P1 is requesting for these resources in this order, that is first it requests for R1, then for R2, then for R4, and finally for R3. So its request for R3 will not be served because it has already requested for R4. So this is in the manner we make circular wait false. So that's all for this particular session of deadlock. In the next session, I'm going to take up the topic of deadlock avoidance. So stay tuned for more good work coming up. Thank you.